time in your schedules this morning to attend our Research Computing Resource Info Share. I want to thank you all for turning out, both those of you that are here and online. All right, I'll try to speak a little bit louder so everyone can hear me. If you have any issues with the audio, let me know. We're just getting started, so we'll make adjustments as we go if there are any issues. And thank you for all our speakers that are turned out here today. Really appreciate you coming out and being here in person to speak about the research, computing resources, and services that you offer to the campus community. I am Michael Shensky. I am Head of Research Data Services for the UT Libraries. And we have worked together, UT Libraries and Information Technology Services, to plan this event this morning. Looks like we're maybe going to swap out the microphone. Let's see if this works any better. Can everybody hear me? Sound better? Fantastic. All right. Hope everybody on Zoom that's attending can hear me as well. Audio is faint. All right. Well, hopefully the new microphone will fix that. If it doesn't, please, for folks that are on Zoom, go ahead and you can use the chat feature to provide feedback for us and ask questions and everything. We're going to have a dedicated Q&A section at the end of the event today where we can answer the technical questions you might have about the resources and services we'll be covering. But if there's any issues with the Zoom session itself, please let us know right away in the chat. So thank you for that. I want to quickly show our event schedule today. So we have a pretty packed agenda. We'll be running until noon today. So we have a whole list of speakers that are going to be talking about services that are offered from different units on campus, as well as services that are provided by local or commercial providers, Microsoft, Amazon Web Services, and Google. All right. Since we are at 10:04, and I think we have covered the basics of this event, I want to go ahead and welcome Lorraine Harricombe to share some introductory remarks.
Okay, let me test. Can you hear me? Everybody on Zoom can too. Okay. Good morning. I'm delighted to welcome you to this event here at PCL, and those who are joining us online to learn more about the resources available to support the research computing at UT. First, I want to thank ITS for co-hosting this event with UT Libraries. Sometimes it's a simple idea that leads to big initiatives. So it was when Michael Shensky and Angela Newell last summer talked about a potential information sharing session such as this one about research computing services. Thank you, Michael and Angela. I don't know that I've met Angela. Are you in the room? Oh, there you are. Okay, good to see you, and thank you so much. In doing so today, they are really highlighting the research computing for the campus community, but also the other research services available here on campus. While today's session is more technical, I sincerely hope that this is the first of a series of events that the UT community can hear about to identify and highlight the rich depth of resources at UT and beyond to support the entire research lifecycle. We can all agree that UT is a highly decentralized, dynamic institution with many independent units that often work in silos. Yes, we do, even though there are new and emerging roles and responsibilities for all of us. UT Libraries is no exception. We regularly assess what we do, why we do it, and how we do it to support the UT's mission, or as Jay Hartzell wants us to be, the world's highest impact public university. That's a call to action, I believe, and is of special significance for stakeholders in research support to create a community of practice within and beyond the university. It is my hope that we will celebrate today as a first step in building productive relationships, campus partnerships, and by getting to know other stakeholders, who they are, and what they prioritize to contribute to the mission of the university. There are likely many other stakeholders in the provision and consumption of research support services who are not represented here today. Still, today represents a major milestone in laying a foundation to build and maintain cross-campus relationships as a strategy to conceptualize UT's research support stakeholders, also known as social interoperability. UT Libraries is a central player in connecting the UT community to resources, expertise, training, and tools. We also provide key research support in several areas, including research data management, systematic reviews, GIS services, and ORCID adoption, to name just a few. Michael will address these topics more in his presentation. However, I want to highlight significant infrastructure investments we have made here at the libraries to offer central access to computer labs and virtual lab for remote software access, the new Scholars Lab that we'll activate in the fall of 23. As you walked into PCL, you may have noticed that. Please come back for that in the fall. The Texas Data Repository, our excellent reference and consultation services, mostly offered online by our librarians and staff, and the LibGuides to help put you on the right path towards your research agenda. I'll conclude my remarks here by stating that the number of attendees, both here in person and online, for today's session underscores the importance of social interoperability in the provision and the use of research support services. I hope today's session is helpful to you, whether you are new to UT or whether you consider yourself a seasoned researcher, so that you may find concrete solutions and/or support for your problems at the right time and at the right place. And if all else fails for you, start with UT Libraries. Thank you.
All right, thank you, Lorraine, for those welcoming remarks. I'd now like to welcome up Dan Stanzione, Executive Director for TAC.
I'll steal your HDMI cable, thank you. Usual switch over overhead. There we go. All that hopefully syncs up in a second. So thank you, Lorraine, Michael, Trice, Angie, for putting together this event and hosting it and for having us here. Hey, we even have the right screen up there. So I am, the Executive Director at the Texas Advanced Computing Center, and I'm the Associate Vice President for Research, so I can get a good enough parking spot to make it to these meetings on time. There's really no other reason for that appointment at this point. So in the very short 10 minutes I have, I'm going to try and tell you a little bit about TAC and mostly what it is we have to offer to campus. I would point out that TAC is largely supported by the National Science Foundation, so we are a national center, but there's a certain home field advantage for you guys here at UT Austin to be able to access some of the resources we have. The sort of roots of what we do, and they've expanded, is having really big computers for the most part. So we have by far the largest systems of any university in the United States. That's Stampede 2 and Frontera. In that picture, that one that is running fully immersed in mineral oil there is Lone Star 6, which is our more Texas-centric systems. But in a nutshell, we operate a whole bunch of different compute platforms with sort of different missions, from very large scale to high capacity to more cloud-like to more batch-like for users both here at UT, around the state, and around the country and around the world. Altogether, at the moment, we have about 20,000 servers, more than 1 million cores, about 1,000 GPUs. We put out 7 billion core hours a year. We ran order 2.5 million jobs last year. And at any given time, we have about 3,000 active projects. We have 40,000 users. We just went over 100,000 accounts at TAC. So, and again, largely federally funded. We've had about $400 million in federal investments in TAC and our people and resources over the last 10 years. We have a step function up, Congress permitting, if the budget actually passes in FY24. We'll start a large new expansion that'll represent more than $1 billion investment over the next 10 years in what we're doing at TAC. So, hardware is not going to be an issue. So, let me go through just the things that we have, because I just can't get through the scope of science in the time that we have that we do. But I will say we've supported at least 3 Nobel Prizes in the last 20 years that I'm aware of. The average machine ends up with about 2,500 journal papers associated with it by the time we retire them. Generally, if there's big science, Large Hadron Collider, Event Horizon Telescope, something you're reading about in the New York Times. We forecast all these storms in California, happened on our machines last summer for all the winter floods. So hurricane forecasting, natural hazards recovery, earthquakes, it just, materials, there's so many different fields. But if there's a big instrument somewhere that generates a lot of data, odds are at least some of the computation happened at TAC somewhere along the way. So let me just spend a few minutes talking about the things that we have to offer the people on campus here. Obviously, the first one is computers. There's lots of them. There's lots of kinds of them, and particularly if you're interested in big ones, we're the place to come. So, but we do run sort of at all scales. We don't use supercomputing or high-performance computing in our name. We stuck with advanced computing for a reason. Basically, when you're doing something and your laptop or your desktop doesn't work anymore, we, along with some of the other providers you're going to hear from, like our friends from the commercial clouds who are here, are one of the places you can go to find those kinds of resources. So we run a ton of single node or even single core jobs. We run 500,000 processor single simulations. Right? All of those things happen across a lot of different scales. As you might imagine, like Frontera, 1.15 million jobs last year. 100 were at that 400,000 core and upscale. The other million were much smaller. So, and like 500,000 were at single node. So, it's all over the map. We have accelerated computing with GPUs, mostly around AI and molecular dynamics at the moment. We have lots of different models. There's the sort of highly managed batch scheduled stuff. You can get bare metal access for sort of CS research. We have virtual machines and containers. We have just run on top of the OS we provide, Kubernetes, Jupyter, large memory, interactive. The sort of 3 big classes of workflows: simulation, artificial intelligence, data analytics. And we're 100% research. There's no sort of administrative load or anything else on these systems. We don't run payroll systems on them. We don't run your email on them. All of that is left to the cloud. So it's just pure science all the time. We also have a couple of visualization facilities on campus, the big display wall in the Peter O'Donnell building over on just up from San Jacinto on 24th. And then we have another one up at the Pickle campus in our main facility, but we have VR and AR hardware, large-scale displays, lots of software for streaming that stuff out. So that's sort of the computing piece. We also have a lot of storage, right? In fact, you're going to hear, I think, probably about some of the library's data management services. A lot of those are back-ended on TAC hardware. Again, lots of kinds, especially the large stuff. We have several petabytes of solid-state storage. By 2025, that should be half an exabyte of solid-state storage. We have a few hundred petabytes of spinning disk, and we have more than half an exabyte of tape capacity at this point. You'll find we have a lot of storage platforms. It's a longer conversation, but just in short, we need to optimize some for speed, some for reliability, some for low cost. It means you have several different offerings, ranging from like really high-speed scratch systems that you can sit on for a few days or a few weeks with your files, to Ranch, the tape archive that has been in continuous operation since 1986. We have data that's, 37 years old, sitting on there. So, long-term digital preservation is a part of what we do. So lots of kinds of storage systems. The most important thing we have, though, is people to actually make all this work. Because systems you can kind of buy. Actually, it turns out that's fairly complicated, which is why all the national labs have come to see us in the last few weeks, because their vendors are all falling apart. But the most important thing we have is a team of people who know how to use all this stuff and help you apply it in your various research work that you do. Again, there's all kinds of those too. I would say especially large, but that mostly just applies to me, not to the rest of the staff. But like we had with computing and storage, but again, obviously it's the things you'd expect, starting with systems administration and actually running hardware. But then we have another 20 people who, focus on application scaling expertise, for different parallel programming models. If you have a big simulation and you're trying to make it work, we have a team just for that. We have another team focused on supporting AI at this point, whether it's hyperparameter tuning or optimizing your I/O as your data sets get big, figuring out how to get, PyTorch or TensorFlow containers running and all those sorts of things and the frameworks. We just actually had a conversation in partnering with Microsoft on DeepSpeed yesterday, the DeepSpeed framework for AI, which will support both on Azure and in-house fairly soon. So we have lots of AI support. We have a lot of people who do training and teach classes in statistics and data science and the computational engineering program over in aerospace. We've taught logic courses in philosophy. We've taught in the information school. I think we've taught in 5 colleges. We have a few people over in the med school. So lots of training support. You'll see courses, especially in the summer, mostly free for all folks at UT, ranging from a couple hours webinar like this to 5-day intensive training courses. We have another team that just focuses on life sciences, genomics, biology, that sort of stuff. We have a Viz team. We have a data curation and management team, mostly people who used to work at the libraries. We have my largest team is actually webs, portals, application programmers. There are 35 people in that team, but people who do user support and deal with your accounts. We have an evaluation team that just looks at grant evaluation that moved over from the College of Education. We have an edge computing and streaming data team now. We have cybersecurity thing. And the other thing is, we're actually fairly good at writing proposals. We're more than 90% grant funded for what we do. Occasionally I feel like I just run a consulting firm near UT. But we have 180 staff and about 160 of them live on soft money. So we work on 70 or 80 proposals a year. So if you need proposal help, especially on things like data management plans and if you're writing for SciSce and computer science, the broadening participation in computing, all those sorts of things, we have a lot of things that we can help with. And again, all of our folks, we have 80 PhD level research scientists who've come through the research game. We understand the research support model and what that means. So I'm running out of time, so just last couple slides here. How do I get access and what does it cost is the next sort of big question that everyone has. So mostly you just ask. Again, we get a lot of money from the National Science Foundation to support users. We have to pretend we're fair and don't favor UT and that stuff, but So we know how that works out. So you can request accounts at portal.tac.utexas. If you have an account and you want to figure out how to do something, you can file a ticket at the portal. You can come to one of the many training sessions we offer. You can just email me, dan@tac.utexas.edu. Trust me, everybody else does. So don't feel like, that's a high bar. But there's also an info@tac email and a help@tac email. Half of those make it to me anyway. So, feel free to email any of those things. On most of our systems, the first tier of access is you fill out a little form at the portal and say, I'd like to use it. And we can just give you the time. For the big systems, there's exceptions where it's just open to any student at any level. But we usually want the project lead, the sort of responsible party, the person we yell at if somebody mines Bitcoins, to be a postdoc or higher. But they can add accounts for undergrads, grad students, whoever, once they have a project created. And because we're mostly NSF funded, we don't stop at the UT boundary. So if you have collaborators at other institutions, we have tens of thousands of non-UT accounts. We can handle most countries, except the 4 that the Department of Commerce keeps us from putting people on from those countries. But although people from those countries who are studying in the US with the right paperwork are also allowed to access the system. So we can span your project. If you're working across 4 universities, no problem. Everybody can have accounts and share data and stuff like that. So the cost varies with scale, but in most cases, it's zero to you. We have UT and UT system paid for programs that allow us to give away time. And I like to say, don't think of it as free, think of it as paid for by someone else. Because that's what it is. It does cost a lot of money to provide this, but I'm still gonna call it the free tier. But if you need something up to like 5,000 compute node hours per year and maybe 5 terabytes of data storage per year, we can almost always handle that at no cost. So that's just a free service we provide by billing other people. And if you're going above that, the next tier up, and where about 85% of our resources actually get handed out, is you write a proposal that's peer-reviewed, where you can get up to several million node hours a year, maybe 100 million core hours per year, and up to petabytes in space if you need it, and consulting time as well from our people. All the basic staff support is included in that, so for 80 or 90% of our people, that's it. In the rare case, I should go the right direction, if you can't get enough time or enough people support through those mechanisms, we also cheerfully take money. Mostly that happens through startup packages, outside companies who use our resources for various reasons, and writing grants together to make that happen. So, and we have rates on all those. So I am now 1 minute or 2 minutes over time, so I'm just going to stop and say, thank my team who puts all this together, including, everybody gets to run cables when we build machines. But we have a big team, and they look forward to working with you, so thanks very much. And I'll stop talking. I'll give Mike his cable back. You're up, Trey.
Hey, Dan. Thank you. Hi, my name is Trice Humpert, and I am the Associate Vice President for Information Technology Services here on campus. And what we are is sort of the large central IT infrastructure group on campus. So I would say Dan is sort of the Ferrari, if you will, or maybe the Lamborghini of technology and compute resources that are available to the researchers. And I'm like the Civic, I'm the one that's got to be there every single day, 24/7. So it's because we run the business side of the university on our infrastructure. So single sign-on, all that sort of stuff runs within our environment. So we're more about resiliency than we are about high performance compute. So it's a little bit different model for what we do. But what we do, we're a group of about 300 employees. We are in the middle of transitioning to this new IT transformation group that you may have heard about with Jeff Nealand is the new lead of that, reporting to the president, and we're part of that consolidation that's happening there. But we do have a lot of services that are available to researchers on campus that I think are valuable to the researchers on campus. And kind of some of those things that we do, we have database services. So we have a staff that supports MySQL, MS SQL, Oracle. We've got a little Postgres experience in there as well. That's a free resource for you to use. We can help you stand up databases and run those databases for you in our infrastructure, so you don't have to worry about doing the Microsoft SQL or the Oracle configuration. We've got a couple Exadatas. We can build you an Oracle database, and you can put your data in there and use it how you want. So we've got a lot of services like that. We've also got the data centers on campus. So if you've got hardware that you need to put into a data center that you want real reliable and dual power, dual cooling, never goes down, we've got those kinds of resources for you. We also run a what we call UTV. It's a virtual machine environment with a lot of storage on the backside. We've made this sort of very user-friendly, and so that we have a panel you can go in, you can select how many CPUs you need, how much memory you need, how much storage you want, how you want that configured, what operating system, hit a button, and in a few minutes you've got a machine that's up there and running and you can start to work on. So you don't have to do the build, rack and stack, configure, all of those kinds of things. We'll take care of all that for you. It is a fee for service, but it's a very low fee because we're subsidized. We don't pay for power, and our data center is subsidized through UT System because we're a regional data center for UT System, and we house a lot of equipment for a lot of the other units around System. So we've got that, and you can spin them up, you can spin them down. You only get charged for the days that you've actually using it. It's better, I would say, at a steady state. It's not you can spin it up and down, but it's really a steady state. We've got a Kubernetes container management environment that you can use. So we've got a lot of those kinds of, if you think about it, the traditional IT infrastructure, we provide that. We also have a group, we call it the Emerging Technologies and Innovation Team, that really specializes in cloud, is the best way to describe it. So we have very tight connections and partnerships with AWS, Microsoft, Google, and we can help you get into those spaces. We have direct connects. So we've got a lot of guardrails set up to make it really easy for you to use those things if you want to go down that path. So we have a whole team that can help you with those things. And if you to get a hold of us, you can just Google UTexas ITS. There will be an email address. You can contact me. You can contact Angie. And we can get you into the right resources. We have a whole service catalog that's out there on the web. If you Google it, you'll find it. Angie probably has those links in a packet that's being sent out, so you'll have all those things. So just reach out. Happy to help in any way that we can to help you guys get going. So some of the things that we've done around research recently on campus, we've built a lot of virtual labs. So researchers need virtual labs for their students. We've been able to stand those up very quickly in the cloud, get their students doing, reset them when we need to, make those things happen. We've done a bunch of sentiment analysis around the president's tweets, just trying to do analysis of how are people reacting to that, what does that look like. We do a lot of those kinds of things. It's kind of interesting. We've built some Shiny apps and interactive web apps with R. That for researchers. We also, one of the really cool ones is we worked with the Del Med, and we did this digital healthcare wallet using blockchain technology, which is pretty cool. You think about, you could carry your whole medical record around it basically on your cell phone, and it's all through blockchain, very secure. So some things like that. And we're just really a partner with libraries and with TAC. We all work real close together. We don't have real hard boundaries between us. Dan and I don't know how many times I've been to TAC, but many, many times. We partner up. We just worked on a grant proposal that got approved for us to do a Kubernetes container package solution for researchers across the country. So really good thing there. And then again, we're really close, what I'll call industry partners with Microsoft, AWS, and Google. So we can help you with those. And just look, whatever we can do to help you guys get your infrastructure for your research projects stood up quickly and get you guys doing research as fast as possible. That's really what we're here to do. And if it's a better fit for TAC, we'll point you at TAC or we'll point you at libraries. But just, I would say, don't be afraid to reach out to any one of us when you have a challenge to figure out how we work together to get you the right solution for campus. Research it's the mission of the university, and it's why we're here. Education and research. That's the reason we're here. A lot of what we do is the business side of the university, because you got to do that too. But really, it's all about the mission. It's all about the mission, which is research and education. So we all want to help support that as much as we can. So look forward to talking with you soon. I'm not sure who's up next. Okay, thank you.
All right. Hi, everyone. Good to be back up here. Again, I am Michael Shensky, Head of Research Data Services for the UT Libraries. I'm going to be speaking to you this morning about the services that we offer to the campus community around research computing. I want to thank everybody that's here today in person, as well as those that are online. I know we have over 50 people online. It's still early in the event. We do have breakfast tacos. Please, for everybody that's here in person, feel free to get up and grab some food and beverages. For those that are here online, if you can make it to Perry Castaneda Library this morning, there are food and drinks available too. I do want to talk today about our support for all phases of the research lifecycle and how we can provide assistance to members of the campus community that are looking to carry out their research and take advantage of the computing services that we've already heard about, some of which we might be able to help you if you are have questions about where to go on campus if you're looking for support. And there are specific resources and services that we offer actually through the libraries that you can leverage to carry out your research here on campus. On this slide, you'll see examples of some of those services that we offer. Again, some of these I will be going into much more depth here in just a minute. Our data management plan tool that we manage for the campus community that you can take advantage of to help you draft data management plans. We offer data through our portals like the Texas Geodata portal. We have many guides that have been developed by our liaison librarians and other staff here in the libraries that can help you get answers to the questions you might have. We also have research data consultation services that you can take advantage of that you can set up very easily through our guides. Just click a button and you can find our availability listed and schedule a time to meet. You can also email myself and our liaison librarians who can provide research computing assistance or let you know, again, the resources that are available to you. We also have many workshops that we offer. I'll be speaking about some of our workshop series. And we also help manage access to the Texas Data Repository, which researchers on campus can use to deposit their research data and preserve it long-term and share it publicly, receiving a DOI that will then be citable so that folks can reference data that has been contributed. I want to start here by speaking a bit more about the data that we share. So at the heart of research computing is data, right? We need data to work with, and we are very fortunate here at UT to have extensive collections in the UT libraries that our researchers can leverage to carry out their work. I've mentioned already the Texas Geodata portal, one of our newer portals that launched in 2019. That provides access to not only the hundreds of georeferenced maps and data sets that we currently have available from our UT Libraries collections, but also facilitates access to the geospatial collections of other universities that you can discover through our portal. And the content available in this portal is continuing to grow. So if you're looking for geospatial data, this is always a good place to turn. We also offer access to data through our collections portal. If you're looking for imagery and raster information, this is a good place to look as well. Again, many thousands of images have already been uploaded there from high quality scans of print materials in our collections. We also have our PCL map collection, which is very widely recognized as a very important and robust map collection. You have access to over 70,000 scanned maps that are part of our PCL map collection that are available through the PCL map website, and many of which are now also available through the collections portal. So these are just some of the sources of data that you can take advantage of through the UT libraries. We also manage subscriptions to many helpful resources that our researchers can access by visiting our library site and visiting our list of databases. I'm just highlighting some of these here, including Data Axle that provides access to really high quality and up-to-date business information, which can be really useful for many different research projects. Simply Analytics and Social Explorer are great sources of information for any projects involving analysis of census data. It really facilitates accessing that information. It's a bit easier to use than the Census Bureau website itself. And we also provide access to digital Sanborn maps too through our subscription to that database. And there are many other databases that we subscribe to that I'm not able to list here and discuss, but you can visit our guide to visit our website and see a full listing of all the databases to which we subscribe. I do also want to speak a bit more about the Texas Data Repository, which launched in 2017 and has become very popular among campus researchers. It is our institutional repository. So it's a unique setup really in that it's managed by the Texas Digital Library, and they manage it not only for UT but for other institutions across the state of Texas. So you see if you visit the Texas Data Repository, some of those other institutions represented like Texas A&M and Baylor, for instance. There is support for individual data files up to 4 gigabytes in size. So this works very well for most research projects. If you're working with very large data sets, that might be a bit of a challenge, but we are currently working with Texas Digital Library and TAC to explore options that would expand that capacity. And it now allows for publishing of data sets larger than 10 gigabytes. So while individual files can't be more than 4 gigabytes in size, if you have many files that are maybe a bit smaller than that, we can support larger data sets. And again, we're still looking at ways that we can expand that further. If you are looking for assistance in reviewing your data before it is deposited and shared publicly, the UT Libraries can provide assistance with that. Both your liaison librarian and myself can provide assistance and general help just using the Texas Data Repository. If you're exploring it, you have questions about how to create your metadata, how to actually go through with the deposit, options for controlling access to data after you share it, those are all things that we can provide assistance with. And one of the great things about using the Texas Data Repository is that as soon as you publish your data set, you'll automatically receive a DOI that others can use to cite it and reference your work. And it's also a great place to visit to look at data sets that have been contributed by other UT researchers. I do also want to speak a bit about our physical spaces. Again, thank you to everyone that's made it here today in person to visit our Learning Lab 1 here at PCL. I want to speak about some of our other spaces as well. The Leberman Media Lab is just next door to us here on the second floor of the Perry Castaneda Library. And I'm really, really excited to speak a bit about our new Scholars Lab that it will be coming online in the fall of 2023, which Lorraine mentioned in her welcoming remarks. We see one picture of that here on the right side of this slide. Here are some other views of it. It's a really exciting time to be here in the library at UT. Everything is under construction there in this space, and really looking forward to the launch of this new lab in the fall, where we'll be able to hold workshops, provide a great brand new lab environment for folks to visit and do their computing that they need to carry out on brand new Macintosh computers. And it's going to be situated right at the entrance to PCL. So right as you'll come in, you'll see this brand new, very nice space that you can study in, that you can work in, and of course leverage that nice lab for working in and for attending the workshops and events that we'll be hosting there. So very exciting. If you're not able to come in person to make use of the computers that we offer through our labs, we do have a virtual computer lab service that I'd like to highlight here that you can visit and access at labs.lib.utexas.edu. We see a list of software that we provide access to through this virtual lab environment. It's very, very easy to log in using your UT EID. You just visit that URL. You'll be prompted to log in. It will allow you to select which type of instance you'd like to set up, and then you are very quickly up and running with a virtual environment in which you can use software, for instance, like ArcGIS Pro, which doesn't run on Mac computers. If you have a Mac and you're looking to use that software, you can access our virtual lab to utilize that, and other software applications as well. If you have any questions about the resources that we offer through the UT Libraries, you can visit one of the many guides that we have up online that are constantly being added to, improved, and expanded over time. These guides are created by our staff and liaison librarians who really spend a lot of effort to make sure that the information here is up to date and providing useful details to the campus community about both the services that we offer and external resources that you can access. And you can see here some of the nice functionality that's available through these guides. You can also very easily access or find an email link to email the point of contact for those specific guides. You can also set up appointments for a meeting with many of our librarians who have that functionality enabled, so it's very easy to set up a consultation session if you have questions that are not answered in the guides. We offer consultations both in person and on Zoom, and so again, it's quite easy to set up a Zoom consultation if you have questions, and also you can email to set up in-person consultations here in PCL. We provide dedicated assistance with ArcGIS Online that I'd like to mention here. So ArcGIS Online is a service that we have a license to here at UT. It's available to all students, faculty, and staff. It is the leading cloud GIS platform. It allows you to store, manage, publish geospatial data through the ArcGIS Online platform. It makes it really easy to create things like interactive maps and story maps that tell a story about your geospatial data. And it can also be used for geoprocessing work, things like geocoding and network analysis that can be computationally expensive and maybe a bit difficult to do on your own computer. You might have an easier time doing those types of things with ArcGIS Online. If you have any questions about ArcGIS Online as a resource, you can reach out to myself, and I would be glad to provide assistance with that. We also offer many workshops and special events in spaces like PCL Learning Lab 1, in which we're in today. And again, definitely looking forward to taking advantage of the new space that will be coming online in the Scholars Lab and hosting events there starting in the fall. Our workshops are very diverse. We like to cover a wide range of research computing topics. Our Data and Donuts workshops are ones that I'd like to highlight here, which are offered every semester. We cover topics like introduction to Python, R, Tableau, really trying to provide these nice learning opportunities for folks who maybe don't have a chance to take a full semester-long course but want exposure to these new technologies that they can take advantage of when they're doing research computing work. We cover different topics each time. These workshops are held typically virtually from noon to 1:15 on Fridays in both the fall and spring. You can visit our Data and Donuts LibGuide to always see the current and up-to-date schedule. And the other nice thing is that we record those sessions too. So if you're not able to attend in person, you can watch the recording later. I will also mention, speaking of recordings, that this session today will be recorded and will be posted after the event for folks to be able to access it in the future. We also offer special events throughout the course of the year, one of which I'll just highlight here is GIS Day, offered in November each year, where we really have a whole day dedicated to the innovative work being done on campus around research computing related to geographic information and geospatial data. The final thing I'll mention here is data management plan assistance. So for folks that are trying to figure out how to leverage these research computing resources and figure out which resources they're going to be using for managing their data, processing, analyzing, visualizing their data, we can provide assistance with your data management plan. There's the data management plan tool that you can log into using your UT EID. It will walk you through the process of creating a data management plan that will satisfy funder requirements. So you can create a data management plan just to help yourself at the outset of a project as you again, plan out what resources you'll need and what you'll be using. You can also utilize this tool to fill out a data management plan for a specific funding agency if you're applying for grant funding. So, for instance, the NIH, NSF, many of the federal agencies that require data management plans, you'll be able to find a template in here that will walk you through the process of filling out all the required information. Our liaison librarians are available to provide assistance with this tool. You can reach out to them. If you have questions, you can also reach out to anyone in our research data services unit for assistance as well. All right, if you have any questions, please feel free to contact myself. Please visit our LibGuides. You can set up consultations and send emails to either myself or your liaison librarian who can provide further assistance. Thank you, everyone, and there will be time for questions at the end, and I'd be glad to answer any questions you might have then. Thank you. And I will welcome up our next speaker from Amazon Web Services.
Good morning, everyone. Well, thank you for the opportunity to talk about how AWS can help our researchers. My name is Alok Takar. I'm the Solution Architect Manager, and I take care of customers, higher ed customers, academic medical centers, and researchers such as yourself. And I have a team around 5 solution architects who report to me. With me, I have Carly, who's the account executive who covers University of Texas, Austin. And Ashu, who is the principal solution architect, couldn't be here, but he is on Zoom. So if there's anything that gets too technical, I will divert to him. I will put out a disclaimer. I do tend to talk a lot. So if I do go over the 15 minutes, there's one takeaway I do want to let you know. At the end of the slide deck, I know Angela said that this will be shared with everyone. There are the very last slide has links. This link is to the Research on AWS page on Amazon.com, and it talks about webinars, seminars, 10-minute tutorials, 1-hour-long labs that are recorded, and very research focused. So I would encourage everyone to look at that after this presentation is done and hand it to you. The agenda is very simple. We'll talk about why AWS, how to engage us, and then who's on the team, because I think that's very, very important. So when you talk to IT, the things that they talk about, we had Trice talk about things that are important to him is reliability, resiliency, cost, and performance, right? But when you talk to a researcher, the equation is completely inverted. Right? It's all about performance, high performance, lowest cost, resiliency and reliability. Okay, that's important, but I think performance and cost are the two most important things. So what do researchers do? They use their handy tool, the laptop, to start building out MATLAB, finite element analysis, whatever be it, right? Now, that works fine, but it only goes so far. Cost-wise, it's okay. It's almost free because you're running it on your laptop, but performance is not there. So you might be waiting hours or days to get the output that you're looking for. And so that's where you kind of go to your IT team and says, I need something bigger. I need to expand beyond my laptop. Do you have something? And the IT goes, yes, we do. We have an array, and you saw that from DAC, right? We have an array of data centers of servers with X number of CPUs, GPUs, and that's fine as well. But the reality is, it's still finite amount of hardware. And in the world where there's new memory types, new GPUs coming on the market, we want to be trying on the latest and greatest hardware, right? Just want to be ready for what's out there. And so this is not this university, but this is a university in the West's HPC cluster. It shows all the jobs that are pending or queuing. Now, it's hard to see, but if you look at the line at the very bottom, it's green. Those are the actively running jobs. The blue is the pending jobs, of the jobs that are being submitted in the queue and that are waiting. Now, the question you want to ask as a researcher is, how long do you want to wait, right? Because performance also means time, right? So if it's performing, you'll get your results faster. You can deviate, correct, and get back on action or get back on course, right? And so this is where the cloud comes in. Because when you start talking about prioritization, malformed jobs, you waited a week, 2 weeks to have your jobs run, only to be kicked back because you said it might take a week. Now it's been 2 weeks running, and someone says, hey, it's taking too long, I'm going to yank it, right? How do you course correct there? And that's where cloud comes in when we talk about data preparation, analysis, machine learning algorithms, things running on data that's already there and present. That's where AWS has a big play there, right? How you expand in the cloud, whether you call it bursting in the cloud, it's cloud native. So there are multiple versions and different services, but I'm going to focus on compute and storage, right? And we'll get into more, and I'll be here for question and answer if someone wants to kind of pick my brain on something that they're working on. But when you look at compute, there's the native, hey, I got bare metal needs. We got that as well, virtualized environment. We got Kubernetes as well, whether it's EKS or Elastic Kubernetes services or Amazon's own ECS. Now, to run all these, you still have to define your EC2 or your compute infrastructure, underlying infrastructure, right? A couple of years ago, we said, hey, we want to make it easy for users to start using these services. Why do we have to define what underlying compute services we have so we can do bin packing? That means more efficiently pack as many jobs as we can on 10, 15, 20 different compute instances. So we released what we call as Fargate, right? So you can run ECS or compute services, container services on native EC2 and Fargate. And what Fargate does is we get rid of the undifferentiated heavy lifting from our customer and say, don't worry about the compute. Just give us your container job and we'll find the right server to run it on. You don't have to worry about how do you scale out or scale up, right? So that's Fargate. And then the third, the most popular one that I see a lot of researchers use is Lambda, which is our compute as a service. And once again, we're going up the stack, right? Before we talked about EC2 hardware, we talked about containerization where you kind of virtualize everything beneath it. And now we're getting into code as a service. So there's no more service to manage. All you say is copy paste your code into the system or into the service, and you basically can write into any of the popular languages like C#, Python, Ruby, and there's so many others that you can just copy and paste your code. And it's trigger driven. So if not used, you don't pay for anything, right? In the AWS free tier, the first 1 million invocations a month are free. So when researchers are trying to kick the tire to see if their grant or what they're going after will work, this is a great way to get started. Now, obviously, there are limitations to that. Lambda only works within 15 minutes, so it's supposed to be trigger-driven or event-driven. So if your services are long-driven, you'd have to look at containers or native EC2. So second thing is, how do you procure it? There's the on-demand method. You can go online and say, I want this particular EC2 instance, and we'll talk about the services in the next slide, right? They're stateful. but they're always there for you, right? If you know your committed rate, that you will be using a basic bare minimum of compute services throughout the year or over 3 period, you can get into what we call as a savings plan, which basically offer around 40 to 50% savings over on demand. And then in Amazon, true Amazon fashion, we have so much compute that's not used. And so how do we make that available to our customers, but then have the flexibility of taking it back when Amazon needs it for other customers? So we call that as spot instances. So when you go in and launch your, let's say, container services, you can say, I want compute.ondemand, compute.my savings plan, compute.spot. And what that does is it says, okay, there's a lot of unused services in Amazon's data center. I'm going to go and pick this particular server. And Amazon says, okay, when there's a particular customer that says, I want that particular server for my needs, we give you a 2 minutes notice and say, we're going to take that server back from you. And that's where you start taking snapshots, you back up your drives, essentially just making sure that you create a stateful backup of that data such that when that spot instance is taken away from you and you invoke another spot instance, you can then start from where you left off, right? So it creates that continuity. All this may sound confusing, but I can assure you when you work with your solutions architect, they will help you and guide and say, this is where you need to use on demand. This is where savings plan would be helpful. Or, hey, Lambda is perfect for this workload here. Now for compute, we go with the t-shirt size approach, right? We have different instances where they might be a general purpose compute. So that's compute to memory. Some may be compute intensive, some may be memory intensive, some may be storage intensive. But in reality, all the different options have micro, large, extra large, 2XL, 4XL, 24XL different options. And all of them just mean different speeds and different memory configurations that are available to you. Talking about the different compute options, you can go for an Intel-based processor, AMD, ARM, whatever you choose. When you talk about high-performance compute, this is a great way to kind of say, I'm going to start my HPC cluster in the cloud, or I can see what I have on-prem and just burst into the cloud. So there are APIs available that you can take your HPC cluster from on-prem, burst into the cloud for those spiky workloads. All in all, there are 300 different permutation combinations of compute instance types in AWS. So let's move over to storage for a quick moment. And I'm going to talk from the top left and go clockwise. So Elastic Block Storage, EBS, think of it like the hard drive that's attached to your server. You can have your operating system, you can have objects or any files downloaded onto it. It's natively available, you can share with others. That's great. But when you start getting into a one-to-many scenario where you're like, I need something like a shared drive, NFS mount, that's where you get into the file storage area. And there's different options once again, right? This is a great migration strategy where you basically say, I need something on-prem where I can cache all my files that are more commonly used, but I need that device to be backing everything up into the cloud when I don't need it, right? So it becomes a migration strategy and an access methodology as well. The third and the most important one is our simple storage service, also known as our S3. As you can see, there's different types of storage classes available, and all depends on how often you want to use it, how resilient you want the objects to be. And by object, I mean, structured data, unstructured data, or semi-structured data with metadata attached to it. There's different permutation combinations. If you're just going to archive data and use it once every 7, 8, 9 years, right? Perhaps deep archive would be the right approach. Or if you're saying, no, I need immediate read after write, then the standard class might be necessary. S3 is also the basis of our data lake and different versions of it. So data lake, health lake, security lake, right? So just because it's so extensible. We can talk about storage and not talk about collaboration. I'll share an interesting story. James Webb Telescope was launched in 2021. I think it was December timeframe. And they were streaming all their data into S3 at that time. It was handled by Space Telescope. And so they had 20 petabytes of data that they were sharing across the world to all the astronomers with the lowest latency possible. Now, this is where Space Telescope was saying, hey, we're the gatekeepers. We're getting all these live data feeds, and we want to put them together and share with others. That's great. And when they decided, hey, we're done being the gatekeepers, we want to give access to everyone who wants this data, they package it up and they gave it to Amazon saying, hey, can you make this part of your open data set? And that's where the collaboration comes in from a researcher's point of view. It's great that you can do your research, but when you want to share, there are many mechanisms of taking your data, desensitizing it. So AWS Clean Room, for example, if you have patient data, you can strip all the data out, and then share with external entities. And it doesn't have to be a ut.edu email address. This is a busy slide, but I'm not going to go through all of this. But when you talk about machine learning frameworks like PyTorch, TensorFlow, Hugging Face, and I know there's a lot of chat about different generative AIs, and you can get into that later. But we do support all those frameworks and services, including Jupyter Notebooks. But the key one I want to talk about is ML Ops, right? We do realize researchers spend, I would say, 40 to 60% of their time with data preparation. So that means data ingestion or data hydration, data validation, and then data preparation. And so we do realize that we need all our services to be integrated with others such that if I can take a stream of data coming in, I can run, let's say, a Lambda to change a particular bunch of variables or add more data to it and then dump it into S3. That's easy doable. So every service that you see here supports MLOps. The few that I want to talk about is, I think they were brought up initially, where the president's Twitter feeds are being monitored. So there are lots of services like Amazon Textract, right? So it's great for digitizing papers. So if you have any forms that are in pen and paper form, which most of them are, right? How do you take that and create a digital copy of it? So that's where we use Amazon Textract, which is in the core services component. And then you get into Amazon Rekognition, which is gaining a lot of focus around whether it be, how do you detect if someone is from a video feed, someone is sad, happy, what are their analysis of, right? And then so you take that and you run that through Rekognition. And then to do sentimental analysis, whether it's text-based or video-based, you send it to Amazon Comprehend, which is the sentimental piece of it. So we're working on a Alzheimer's research, trying to figure out the progression of Alzheimer's based on their text, their speech, how they blur, how their facial expressions change. So we're taking input from both Amazon Rekognition and other services like Transcribe, and then feeding them into Comprehend so we can see, is this person going from happy to sad and at what moment, right? So lots of interesting things happening around the machine learning side of things. So how we work with researchers, this is a very important slide, right? It's a 5-step process. We go through the whole cycle where we can do one-to-one, one-to-many seminars where we do come on campus, and we call them immersion days, but it's basically we sit in a room with one researcher, many researchers, and we can run labs. Labs can be on a specific topic or it can be architecturally based, right? We can help identify grants as well, where if you're trying to do a proof of concept and you're like, I need to vet this out before I put this in for a grant, we can assist with that. We do have ex-researchers who have helped researchers write the bid, right? And we can also offer a letter of collaboration. The most important thing when you start building on AWS is, well, trying it out, right? Because the whole concept of using the cloud is fail fast, but then change your course of action and then build again, right? So we do offer a lot of credits, and the links that I mentioned will walk through how we can get you credits and other services where we can provide you the startup funds that you need to start building on AWS. This is something that's near and dear to my heart because a lot of the solution architects that report to me do a great job in deploying scale, and I hold them personally responsible to see how we can optimize their workflow. So one of my previous customers, they were running a open search cluster. It's basically a way to kind of search what kind of data they have. We're able to reduce their spend by 40% just because after 2 years of working, we went back and says, hey, we can do a better job in optimizing and getting your bill lower. So just kind of pointing it out that it is a tenet for my team to optimize once things are up and running in the cloud. And then, like I said, we're building community, right? So one of the links, like I mentioned before, it's all about the blogs, the white papers on what other researchers have done. So once we go through the entire cycle, we'd love to be your advocate and have you contribute towards those workshops and those slides and those success stories as well. So who's on our team? Here are the list of 7 people on our team who focuses on research. Now remember, like I said, I focus on higher ed, AMCs, and research, right? I have a separate team for higher ed, a separate team for medical centers, and a separate team for researchers. So these 7 people are dedicated to research. Now, if you don't remember anything, just remember this. Out of the 7, 4 of them are ex-researchers. They're PhD students, PhD graduates who've worked in the research faculty, done lots of publications, and they know how it works. They worked on the cloud, so they can come up with a lot of ideas. And reality is they can ideate with you as well. So if you're not unsure, or if you are unsure on something, these folks will be a great place to start and bounce your ideas off of. And I don't know how I'm doing on timing. It says 17 minutes, so I've definitely gone over. But here are the 2 links. The slides will be given to you, but I'll definitely encourage you to check it out once the session is done. I know I'm over time, but does anyone have any questions? I'll take that as a no, but I'll be here, and most of us will be here, so after this session, hunt me down, and would love to chat with you guys. Thank you.
Good morning, everyone. Oh, I know we can do better. Good morning, everyone. Oh, much better. Well, thank you all so much. You know, before I started in this presentation today, I was extremely nervous to talk to each of you because you all are doing incredible things. And like any good, prepared person at Microsoft, I turned to ChatGPT to make sure this presentation was excellent. I asked ChatGPT, hey, what do higher education researchers care about most? And it was everything from student success, institutional effectiveness, and that's great. But I actually talked to a lot of you in this audience today, and a number of you are talking about how do I get my compute, my storage, how do I make sure that if I don't need it, I can reserve it for later. I understand that. And also, finally, I asked ChatGPT about a good joke, and I have to share this with you all because this is just too funny. ChatGPT really gets my heart. Why did the academic researchers decide to move their data to the cloud? Because they wanted to reach new heights in their research, literally. Okay, I got a couple chuckles there, I know. Definitely pity laughs. My name is Chris Aiken, and I am the lead for UT System. I'm joined by Charles Rice, who is our principal architect, and Megan Davis in the back, who is our cloud solutions specialist. And the 3 of us here are your local account team, and we work closely across the UT System, and especially UT Austin. Today's conversation, you're going to hear from all different walks of life around cloud computing, from different players and different groups that we partner with, especially with ITS, with Trice and Dan, with TAC. And really, you look at it, you look at the compute storage and everything else that's there. Yes, that's great, we can do that. But I want to show you what differentiates us and how we can make that better for you. And the partnership that we have with OpenAI is transforming the way that researchers engage with us on a really awesome level. So Charles is going to walk through resources that you have access to, a little bit of the storage and compute, and then some of the really differentiation that I think you guys would really enjoy today. Charles, over to you.
Thanks, Chris. Good morning, everybody. Charles Rice, Principal Data and AI Architect with Microsoft. Before I get started, I'd like to invite everybody to join this community. This is a community called Azure Hour for Education. It's a community of your peers, about 2,900 of you from coast to coast. They get together every Friday at 1 o'clock, talk shop, what they're doing in the cloud, and usually we'll have the topic of the week in a Q&A session. I help co-host. We also have 5 different smaller office hours. I help co-host the Data and AI and the Research office hours. Go to this link, AKMS.edu Azure Hour, and you'll be presented with the schedules and an ability to join the Microsoft Teams community where you can converse with your peers and join in the conversation. I also want to make sure that everybody in this room knows that as part of being, UT employees, UT System employees are all eligible for free training from Microsoft, both instructor-led and self-paced learning. If you go to esi.microsoft.com, log in with your utexas.edu credentials, and you'll be presented with a variety of options, not just Azure. Obviously, I focus on Azure, but not just Azure. A variety of training, and the idea is to train you up, get your certifications, and be like more of an authoritative expert in cloud and other Microsoft technologies. Additionally, I want to mention that if any of the researchers either in the room or on Zoom are doing life sciences research with the NIH, in other words, NIH-sponsored research, you're able to get a 20% off discount in doing that research in Azure because we're part of the NIH Strides program. So if you're interested in that, please let us know. And if you want to get access to Azure, this is the easiest way to do it. If you go to this short link, AKMS-UT/GetAzure, this will take you to Trice's ServiceNow portal where you can fill out the form and start the process to get UT, an Azure subscription for UT so you can conduct your research in Azure. As Chris said, there's table stakes, as I call it, and differentiators. I think the 3 table stakes for academic computing, if I were a research, would be optimized compute, high-performing storage, and workload orchestration. If some of this sounds redundant compared to the AWS conversation, that's because I think we all agree on that. As far as optimized compute, Azure by far has the greatest, most variety of compute options available to you, everything from single node instances to all the way up to bare metal Cray clusters in Azure, like full Cray clusters in Azure, HPC clusters in Azure. We also have HPC specific SKUs in Azure. This is just some of them. Going left to right, sort of the smallest, oldest to the most newest instances. And if you see on the far right there, there's the newest HPC specific nodes that we have with the AMD EPYC Genoa chipset and 400 gigabit per second InfiniBand interconnect. I believe we're the only public cloud that has true InfiniBand for our compute instances. We also have GPUs available to you, a wide variety of GPUs, everything from visualization to deep learning. This is just some of them from the M60, Tesla M60 to the NVIDIA A100. We have nodes with multiple A100s. The one on the far right is the 8 A100 NVIDIA GPUs with up to 200 gigabit per second InfiniBand EDR interconnects. And when I say nodes, yeah, this one has 8, but you can put a lot of them together. We have some customers with 80,000 and 100,000 cores working together as one giant cluster. And lastly, announced maybe a month or 2 ago, we have the latest NVIDIA H100 Tensor Core GPUs available. Just like the A100s, there's 8 of them on here. The big other than the GPU, the big difference is, unlike the A100 nodes, this one has, again, the 400 gigabit per second InfiniBand interconnect. So if you're into those tightly coupled MPI jobs, InfiniBand is InfiniBand and the higher gigs per second and the low latency is going to be what you want. We also have confidential compute. So we've had storage at rest for forever. We've had storage in transit for forever. And Microsoft Azure was the first public cloud to offer storage while in use. So effectively, encryption while in use. So effectively, as you're processing the data itself, the actual processing is encrypted and secure. And it's not just for virtual machines. We have confidential computing for SQL. We have confidential computer for AKS, or Azure Kubernetes Service. We have confidential computing for IoT edge devices, and we work both with Intel and AMD on confidential computing. So there's a clear differentiator for us. And I'm trying to cruise through this because we have very little time, so I apologize. If you guys want to have a conversation after the fact, feel free to reach out to us. High performance computing, by far, most diverse set of storage options in Azure, everything from very small disks to Cray Cluster Store as a service in Azure. The backbone of Azure storage is what we call blob storage. It's analogous to S3. It's also called ADLS Gen 2 or Azure Data Lake Gen 2 because it's multi-protocol. I think on the AWS side or slide you saw S3 as sort of re-engineer, refactor, and then you had the other ones for bringing in like clients that can communicate with disks or NFS or what have you. ADLS Gen 2 is multi-protocol, and what that means in essence, it can speak different languages without introducing additional services like a storage gateway in between it and its clients. So one storage account operating on the same storage objects can speak with the REST APIs, the native REST APIs can speak with NFS, can speak with HDFS or Hadoop file system, can speak to SMB, can speak to SFTP, so effectively you have a SFTP server without a server directly to the storage, and some other protocols. And as you see this sort of arc on the top is a life sciences example. This is DNA sequencing. So you're primarily ingesting the data with the REST API straight into ADLS Gen 2. Then the secondary analysis is using NFS because perhaps the secondary analysis tool only speaks NFS, so we're able to work with the same storage objects that are in the storage account with NFS. Then we're using HDFS to do tertiary analysis on the DNA. And then finally, we push it to Azure Machine Learning Service, again, with the the REST APIs. And just like in AWS, we have different tiers, everything from premium to deep storage. And it's just exactly like AWS. We, the higher cost for storing it, lower cost to transact it for the premium. And as you work down, lower cost to store, higher cost to transact against it. We also have HPC cache. So while Azure Blob Storage and Data Lake Storage Gen 2 is very performant, for those tightly coupled jobs, latency is the king. So what we do is we put HPC cache in between blob storage and your HPC jobs, and that sort of hydrates as a cache and dumps the data into your nodes at many gigabytes per second. I mentioned earlier we have Cray Cluster Store as a service. So just Cray Cluster Store. If you're used to working with Cray and Lustre, this is effectively it, but we manage it for you. And finally, we announced this a couple months ago, I think maybe January or February. We now offer Azure Managed Lustre as a service. So Lustre, again, is Cray Cluster Store is also Lustre, but this is not Cray. This is Microsoft-owned managed Lustre as a service. The idea is you can spin up Lustre volumes and hydrate those, use those for your MPI jobs or your HPC jobs as they're running in Azure. And when you're done with it, and you can destroy it and walk away. Also, Azure by far has the most resilient and durable storage. The cheapest option we can give you is 11 nines of durability, LRS, locally redundant storage, and the most expensive option is 16 nines of durability, so 99 plus 14 more nines of durability. It's globally redundant, or GRS. Workload orchestration, three different, there's lots of them, but these are the main three ones when I think of HPC. Azure Batch is our scheduler as a service, and Azure fully abstracted. This is if you have no legacy dependencies. This is if you want to start cloud native. Azure Batch is effectively, like I said, the scheduler as a service. You give it your jobs, you define your task, and away you go. It sort of figures everything out in the background for you. Azure Kubernetes Service, this is maybe a more modern way to do it. If you have, no dependencies at all, and you're not maybe a HPC person, maybe Azure Kubernetes Service is what you want to consider. This is a fully managed Kubernetes orchestration service, free, by the way. The service itself doesn't cost anything, so if you want to deploy Kubernetes, AKS is the service to use in Azure, and I have, as an aside, a UTMB researcher right now using Azure Kubernetes Service to command robots in the Galveston National Lab in Galveston to mess with the COVID virus, to do an assay on them. So it's a kind of a neat sort of wet lab, cloud, AKS, very cool thing that they're doing. He's presenting actually coincidentally on Azure Hour on the 31st of this month at 1 o'clock. If you guys want to go back to that previous link and see what he's doing, it's very innovative, very inspiring work. Finally, CycleCloud. This is our answer to, okay, you're an HPC researcher, you're used to using on-prem, you're working with TAC, you're used to using Slurm or what have you. Azure CycleCloud is the tool you can use to use the tools you use today without having to change a single line of code and burst it into the cloud. And it supports all the major schedulers. So I know TAC is a big Slurm user. You can use Slurm in Azure CycleCloud, in Azure through CycleCloud without changing a line of code. We support many more, and you can bring your own. We support all the different file systems and such too. So let's talk about differentiators now. This has all been table stakes, I think. If I were a researcher, these would be table stakes. Differentiators, by far, security compliance is where Azure stands out, hard stop. We're the only cloud provider that's also a security company. No one spends more money than us on proactive security research. No one has more security experts than us. And no one has more daily signals that we analyze and help you with than us. And it's not just us saying it, it's the big sort of, Forrester, Gartner, all those folks are saying it. Microsoft's the only cloud provider that is also a security company. It's not just security in the sense of antivirus and malware, it's security in the sense of compliance. By far, Azure is the most compliant cloud. And as we start having these conversations with the federal agencies like DoD and more as CUI and CMMC gets more prevalent, FedRAMP, TexRAMP, HIPAA, Azure is the place to be because we've got you covered. This is, a placemat of names and acronyms, but that's not all of them. It's also not just United States compliance that we got you covered. We got you covered for compliance globally. So if you're collaborating with peers of yours across the globe, Europe, Asia, what have you, chances are we've got the compliance services and certifications for you. The backbone of compliance and staying compliant in Azure is Azure Policy. And what this is effectively a way to enforce configuration for your solution once it's in the cloud. And it basically has built-in initiatives, what we call them, for like CUI, FedRAMP, NIST 853, NIST 800-171, HIPAA, HITRUST. You apply those initiatives at a high level in your environment, and it enforces configuration down the hierarchy of your environment, so that you can not only ensure that you remain compliant, but if you were to happen to get out of the guardrails of compliance, you get a real pretty dashboard that's easy for anybody to consume and understand, broken down by the specific. In this example, it's NIST 853 R5. In this example, you can see the different control groups and individual controls and individual resources that may or may not be compliant. And as you click into those, it tells you why they're not compliant. It tells you how to fix them. Oftentimes, there's a one-click button you can use to fix them. And like I said, this is the backbone to maintaining compliance in Azure. But it's not only available in Azure. So you can use Azure policy initiatives in Microsoft Defender for Cloud across, obviously, Azure, but across also AWS, GCP, and on-premises. So you can effectively start up a secure enclave on-prem, AWS, GCP, Azure, using the Azure policy initiatives to put the guardrails in place and have everything sort of come up in this dashboard for you, so you see the entire security footprint for all your environments, not just in Azure. Chris mentioned OpenAI, so that's the second differentiator I think that we should talk about. So Azure's had a broad suite of AI and ML tools for forever. The backbone of our AI tools, or AI as a service tools, has been Azure Cognitive Services. These are broken up into 3 different domains: vision, speech, language, and decision making. And within those domains, we have different models, right? So speech recognition, text translation, sentiment analysis, that kind of stuff. This has been around for years. Lots of users are using it. Really easy APIs to interact with, really easy SDKs, Python, C#, so on, to write your software with. We've also have a really broad and industry-leading suite of machine learning tools and resources. Fully managed ML sort of services, but you could also bring your own, right? You could bring PyTorch, TensorFlow, Scikit-learn, Onyx, whatever you're using today, you can bring it to the Azure Machine Learning Service and conduct your machine learning training and enrichment and research as you were doing it on-prem, but in a much more potentially secure, compliant environment with less overhead. And finally, this is what's been getting all the headlines right now. If you guys don't know, OpenAI actually runs on Azure. So not only does OpenAI run on Azure, but you can spin up your own instances effectively of OpenAI and get access to all these models you see on the screen, everything from ChatGPT 3.5, GPT 3.5, GPT 4, ChatGPT Codex, and DALL-E. And under those, there's about 25 or 30 different models, so you can sort of switch things around to get sort of more cheaper and less accurate, or more accurate and more expensive. So you have the ability to massage things if you spin up the Azure OpenAI service. So you may be wondering, why would I want to use Azure OpenAI service when OpenAI themselves offer, I think, what they call OpenAI Plus, to give you paid access and priority access to OpenAI. And the reason is because we've wrapped our enterprise grade offering around OpenAI. So the same compliance and security protections that differentiates Azure across all other public clouds are in Azure OpenAI service. And we've also wrapped around our security and privacy measures. So if you didn't know, if you're trying to use the public OpenAI service and you're trying to fine tune it with your own data, there's potential for your own data to become part of the public model, right? That's kind of scary, especially if it's publications that haven't been, or research that hasn't been published yet and so on. Within Azure OpenAI service, we put guardrails around your data so that your data remains your data. You can still use your data to fine tune the model to make it more relevant for you, but your data doesn't get put into either the larger Azure OpenAI service or the public OpenAI service. And like I said, Azure is the most secure and compliant cloud, so everything you do within the Azure and OpenAI service is protected by those same controls across the board as they would be with anything else in Azure. Any questions? I think that was a record. Any questions, comments, concerns? I don't know if we mentioned Chris and I are both alumni, right? So Hokum. I went to McCombs, you went to Moody. So we're also based in Austin, as is Megan Davis in the back of the room. So we're all based in Austin, happy to come back. Always a pleasure to come back to campus. Easy drive for us. AI for Good. So yeah, actually, I guess I skipped over that. So we have, responsible AI is a big deal these days. Microsoft's been a leader in responsible AI for many years. We also have AI for Good is sort of like a side thing at Microsoft where we've divided AI for Good into different categories: AI for Earth, AI for philanthropy, AI for humanitarian, health, different domains, and we effectively use our tools and our responsible AI practices to just help humanity. Our mission, I think, is to empower every person on the globe to do more. So it's not just every person that pays us, we're trying to empower every person. So we're trying to use our tools to impact things like, I think there was something in South America where Microsoft was helping like refugees, for example, using our AI and technology tools. So that's another, is there anything else you want to?
Clean water initiatives, things along that. So like it starts to come into work and research with NGOs.
Yep.
But as it pertains to the people in this room, we also have grant programs available that are associated with AI for Good.
I'm about to reiterate what she says. So she said we work with NGOs, so on and so forth, and we help write the grants and help you get access to the resources you need to make an impact on the earth in a good way using our tools. Is that effectively? Yeah.
So
Okay.
there are grants available through AI for Good.
Grants available through AI for Good. Thank you, Megan.
Cool. All right.
Thank you, everybody.
Thank you.
We good back there? Hey, good morning, everybody. Thank you so much for having us out. My name is John Drew, and I'm part of Google Cloud's higher education practice. I have the privilege of working with university systems like UT and many others here in the state of Texas. I'm joined today by my colleague Volker. He's one of our research practice leads, and you're going to hear from him in just a few moments. I thought the place I would begin is talking a little bit about what it looks like when Google shows up and works with a research institution. I'm going to quickly run you through some headlines you may have seen in the news, because I think they're pretty emblematic of the type of work that we do, as well as the type of stories that we seek to amplify. One of the first stories that you may have heard of broke just last year. It was from January of 22. Stanford led a group of several universities alongside Google, and we sought to break the Guinness World Record for the time it takes to sequence the human genome. And we completed it in just 5 hours and 2 minutes. The prior record at that point, I want to say, was something on the order of 8 days. It's a wonderful story of what just sheer horsepower in the cloud can do when hours matter. One of the reasons time mattered so much in this use case, they were looking at newborn babies in the NICU who were quite ill, and rare genetic disorder was suspected. Treatment really could not be given until they had definitive answers about what was wrong. And I think you can imagine being a parent being told, sit tight, we'll have answers in a week. You're going to see a lot more stories like this in the coming years, dominoes falling, records being broken through just sheer horsepower. One of the other trends that we're seeing in academic research is research quickly moving, particularly true in the life sciences space, from research to clinical application. A couple years ago, Google teamed up with Emory and developed something known as Deep ACE. ACE stands for AI Sepsis Expert. And what they did is they built a model that would take real-time telemetry from ICU patients, and they were able to very, very accurately predict the onset of sepsis anywhere from 4 to 12 hours before it was something that could be diagnosed clinically. So we were talking about very, very sick patients already, and through AI, we were able to help them fall into further states of risk. One of the quotes that came out of this story always stuck with me, and it was, AI is quickly becoming the microscope of the 21st century. But it's not rationalizing over biologic specimen, it's rationalizing over data. The last story I wanted to share with you comes from much, much closer to home, right here on campus, as a matter of fact. In fall of 21, a researcher by the name of Dr. Casey Claiborne actually won the inaugural Google Cloud Customer Award. Her team over at the Dell Medical School did some really, really interesting work in terms of fighting the opioid epidemic here in Texas. And what they did is essentially use Google Cloud to build out a citizens reporting platform that would allow them to report overdose incidences, and it would allow harm reduction organizations to find out where the hotspots are and all those types of things. Although this program's been going on for a couple years, it's just now being rolled out in some major metropolitan areas, so you're likely to hear more about it in the news, and I can tell you it is already saving lives. We were really, really delighted to shine a spotlight on her amazing, amazing work. One of the first questions we often get asked is, where do I get started and how in the heck do I fund these types of things? We have a self-service portal that each and every one of you could go to today to apply for academic research credits. Google's pretty generous, I believe. Individual researchers can qualify for grants up to $5,000, and even PhD students can apply to receive up to $1,000. Please note that is not per university, that is not per department, nor is it per project. That is per researcher. It is a one-page application form. Please don't write a dissertation to us. We won't read it all. And we typically get back to you in about 3 to 5 business days. It's a really, really quick and easy way to do it. Depending on the type of research that you do, you may qualify for much, much larger grants. Each year, we sometimes change the theme of these. This was one we launched last year, and it's known as the Google Cloud Climate Innovation Challenge. So for anybody who's doing work in the climate science space, I'd really encourage you to apply, because grant awards there can be up to $1,000 in size, or excuse me, $100,000 in size. One thing I want to make sure each and every one of you leave here knowing is that Google Cloud Platform is definitely available for you inside of UT's main environment. If you simply do a search for Request GCP from your homepage, you'll see this link that I have highlighted there served up. Click on that link, it'll take you to a little form to fill out a ServiceNow ticket, and it will put you in touch with the custodians of the Google environment here on campus. That happens to be the Emerging Technologies team. We do meet with them regularly, and we can gladly provide consultations in terms of pricing, in terms of architecture, and those kinds of things. One other thing I want to mention. Google's been not only innovative with technology in the cloud, we've also been very innovative with business models. We have the ability to deliver to you something known as a subscription agreement. It is a flat, fixed fee for a defined workload, even if your use of cloud resources is variable. As far as I know, we're the only provider doing this. It's not just about reserving a machine or reserving storage. It's a defined workload, and Google saying, we will take on the risk for your variable consumption of this. It's really, really innovative. I'm going to turn it over now to Volker, who's going to talk a little bit about why Google Cloud has been such a popular choice for researchers historically and what some of the tools are behind that.
Thank you, John. Can you hear me okay? Sounds good? Wonderful. So let's dive a little bit into what this actually allows you to do and why you would want to pick Google Cloud for scientific research. Just a little bit of background. So I'm a computational chemist, computational biologist by training. I've done this in a commercial context for the better part of the last 15 years, joined Google about 4.5 years ago to do what I learned applying Google Cloud as well as other cloud providers to our commercial research projects, applying this to a variety of projects across the board, commercial, academic. So what I found through my own experience, but I think what a lot of our customers also find is Google Cloud is a very intuitive, very well integrated across the board, very straightforward to get started with platform. We're not here to compare one level of intuitive and simple against another, but I found it to fit like a glove, right? And I think that counts for a lot when you're trying to get research work done. We've been very open about our research. We've been very open about our technology. It's been a major contributor to open source projects across the board. That could be data, that could be compute, that could be AI, ML. We'll get to that in a minute. So from that perspective, it's very straightforward to get started. One thing, and I think that comes out of us having a very broad footprint also in consumer products, but very collaboration capable, right? A lot of you are probably familiar with the likes of Gmail, et cetera. Gmail is a communication tool, if you want to call it, but the collaboration aspect that is built into Gmail, Google Docs, and the like has really set a standard that people now expect these days. That same level of collaboration you can apply to cloud data science projects, research projects that you may want to run with the help of cloud technologies. I think we have a very long and very, well-established history with AI/ML. AI/ML is in everybody's news feed these days, so we'll talk about this in a minute. But we've been doing this for the better part of the last 15 years, have contributed major components, for example, TensorFlow, to the ecosystem or the research community out there. So I think from that perspective, in a research context, being able to access open source tools, being able to use the latest and greatest for the research project that you're trying to operate on, and being able to have, instant recognizability or familiarity with tools because you may have used them elsewhere counts for a lot. Trusted, no need to belabor this. Obviously, a lot of projects that people work on these days have very tight regulations, security controls, et cetera. We support that. Probably is not a good use of our time to go through all of that. Happy to chat about this. We have, of course, also, again, through our consumer exposure, been very active in the security space, right? You can probably understand why we would have to do that, given that we are a major target ourselves, and we pass that security footprint on, or that security capability onto others in the cloud. So, okay, sorry, I'll move this up a little bit. Is this a little better? Sounds good. So how do you get started? So we decided to take a slightly different tack in terms of like how we approach this. A number of speakers have said this now. There's a certain amount of table stakes, compute, storage, connectivity that one has to provide in order to operate a cloud that actually is useful and works for, in particular, large-scale research projects. So what we offer, of course, is a full complement of virtual machines, Kubernetes, which originated at Google, storage solutions covering both blob storage all the way to high-performance computing storage or POSIX-compliant storage for high-performance computing projects. But I think not everybody needs this on day one. There's a lot of domains where you don't need this. If you're a data scientist starting out with quantitative projects, and a lot of research, most research these days is quantitative and data-driven, you may just need a computing environment in which you can do analytics. Some of you may be familiar with Google Colab. It's a very, very accessible service, zero ops, takes no effort. Log in, use Google Drive as your storage mechanism, do data science. You get a certain amount of GPUs for free in that environment. It costs you nothing, right? So that is a super easy entry point for someone wanting to do data science on Google Cloud. It's Python focused, lingua franca of data science these days. We'll get into options in a minute. Integrates very well, and I know this is a little bit hard to see, but integrates well with existing services. If you have data in Google Sheets, you may have data in Google BigQuery. You can easily access that from Colab as well. But you may outgrow this, and once you outgrow this, you need a different solution. You don't want to necessarily roll your own. You may want to consider Vertex AI Workbench. We'll get into Vertex AI as a platform in a minute. But basically what Vertex AI Workbench is fully managed Jupyter notebooks that let you access the full complement of Google Cloud services as well as external services. If, for example, your data is stored in S3 bucket, why would you want to be limited? You can do all of that from AI Workbench, but you have a lot more capability in that environment. What I think is also important, this has come up early, and this may be a little bit difficult to see, but you have access to a much larger set of kernels that you can run. A lot of people do R, a lot of people do TensorFlow. So Vertex AI Workbench supports all of that. So that's kind of when you graduate from Colab, you may want to consider that. Now, what is Vertex? Vertex AI is an end-to-end data science platform, basically. Heavy focus on AI/ML. Not all data science is AI/ML, but a large part of it is. Speaks to a vast or broad range of audiences through low-code solutions or no-code solutions in some cases, all the way to custom models that you may develop, custom frameworks that you may want to bring in. So Vertex AI basically takes you from beginning to end in a data science AI/ML workflow, right? We cannot go through all of this. Happy to connect on this after the fact. MLOps has come up earlier. Critically important, I think, especially for researchers. You want to spend your time researching, doing science, as opposed to worrying about MLOps, how to push out a model, how to make it scale, how to secure it. MLOps and Vertex AI can help you with all of that. So when you start out, you may have a data set that you want to categorize. You may not want to build models yourself to understand what is in my data set, what is in my image data, what is in my video data, for example. There's a large number of pre-trained models that we use in production ourselves and that we give access to customers that you may want to use in your research project. Now, I understand in some cases you may not, that the data that you work with may not fall into those categories. That's where custom models would come in. But you will be able to cover a large number of use cases using those pre-trained models. They improve over time, of course. They're actively developed by us. So you will be able to take advantage of improvements in those models without having to really do anything. So last but not least, I think there's always a whole journey from beginning to end, of workflow from beginning to end that one has to consider in a data science project. And I talked about integration earlier, how intuitive the platform is, how straightforward it is to get started with it. And I think what we would probably highlight as one of the critical elements in Vertex AI and the whole ecosystem on GCP is the very much integrated data to insight journey, right? You start out ingesting data, for example, early stage data engineering. You may want to push this through Dataproc, which is basically managed Hadoop. You may want to use Dataflow, which is Apache Beam open source. Push that into a data warehouse, BigQuery. Then act on that using Vertex AI. So that's the core data science part. You may not want to engineer a little bit on that ML once you have a viable model. And now you want to understand what the model actually does, who uses it, how, what does this actually enable. I think that's where we shine, the end-to-end integration of the services, the accessibility, and basically the ability for a researcher or researcher's ability to cover this end-to-end in the same platform without any intermediate steps, taking data out, re-importing it, et cetera. So on that front, I think we're doing very well. What I think everybody doing data science, and especially AI/ML, will notice sooner or later, models can be opaque. It's not immediately clear why they come to the conclusions they come to. What do we do based on the results that the model generates? How do I build trust with end users, right? Like, how do I tell them this is actually what the model tells you and here's why? We spend a lot of time on this. With AI/ML taking front row seat in a lot of research projects, oversight and risk management is critically important. There have been a number of instances in the news in the last couple of years where this has gone tragically sideways. We want to be careful about how we use those models and monitor them as much as possible. So that's why we focus a lot on explainable AI. Why does the model predict what it predicts? Why does it make the recommendations it makes? All of that is built deeply into Vertex AI. It is not a bolt-on. It's not a separate step. It is something that is from beginning to end integrated into the platform. Again, we can talk details how this actually works. What I think is also important in order to be able to realize that, though, is your models need to be able to run at scale. They need to run reliably, and they need to run over time on an ever-expanding corpus. If your model was developed 2 years ago and trained on that data set, Does it still perform the way it did 2 years ago? Has it now, through that larger corpus, taken on a new identity? MLOps can help you manage drift or detect drift, manage drift, retrain, do that very quickly, and then push out a new version of that model. To do that, you use a variety of frameworks, but I think you need extremely good, capable hardware. Hardware was a major topic today. We're not going to dive into it. Everything we have, as I mentioned, the full complement of hardware services. One thing I think that also stands out on GCP is we have what are called tensor processing units, so a custom-made silicon for TensorFlow, extremely capable, can train extremely large models, and is accessible to anybody on GCP. All right. So last but not least, and John, I think you may want to be the one covering that.
Yeah, thank you so much, Volker. We obviously didn't have a ton of time today. We really appreciate the opportunity. We do want to invite all of you to join us just about a month from today. We'd love to have you downtown at our offices here in Austin. We're going to be conducting a full Google Cloud platform for research. I believe the registration page just went live yesterday, so I'm delighted that you're the very, very first folks that are going to get invited to this. Volker and I will be sticking around afterwards if you have questions. Hope you do come join us. Thanks for your partnership. Thanks for letting us be here.
Hi, everyone. I am going to be setting up for our next speaker, who's going to be presenting virtually. So if you give me just 1 minute, we will try to get them patched in through Zoom here. All right, so our next speaker is Eric Weigel. And let's see. Okay, great. All right, so Eric is going to be speaking to us about virtual labs. And fantastic. And all right, let's see if we can get audio. Eric, I don't know if you can. All right. We can hear you. It's just a little faint. So we can see the slides, but we don't hear any audio right now. Thought we did hear him for a second. Oh. Is my audio? No, I have audio turned on. HDMI plugged in.
What audio source is coming out of there?
Oh, yeah, go ahead. Oh, interesting. So they can hear him through the Zoom. All right. So it sounds like folks that are on Zoom can hear Eric, but we can't hear him in person.
Right.
So sorry for the delay here. We'll take just 1 second. Get this figured out.
Find your settings.
the Zoom setting that's the issue.
Let me see. Oh, look, I think you're muted.
So then they can hear us.
They can hear us, okay. There you go.
We'll have to mute.
Yeah.
How about now? Should be back up.
Good morning, everybody. It's on? Hi. Thanks for being here, and thanks to Michael for the invitation to talk. I'm going to give you something that I suspect is a little bit different from what you would expect and what Eric would have provided, which is normal use cases for high-performance computing. I'm a humanities scholar. I am specifically an archaeologist with a foot in digital humanities and strong interests in computational photography and linked data and long-term data management. So let me get set up here. And let me begin by noting a couple of things in response. I wasn't sure who was going to be here or who I'd be talking to. I think in many ways I am probably talking to some of the representatives of the various high-performance computing groups rather than other researchers. So let me key it to that, and let me note two very specific things about humanities researchers. We had a bit of a discussion about cost with AWS and with the other providers. So for humanities, we have very little money, so usually we are looking for a cost of zero. And we also tend, when we have some money, to do highly customized, extremely complicated, very individualistic things for which we have no long-term maintenance plan. So we will make something very complicated with lots of dependencies on whatever resources we have, often local computers, and then we will hope that when we are done with it, it will just sort of last on its own for the next 10, 15, 20 years. Not what happens in the computer science world, and not usually how the natural sciences, for example, are using their data. So my fieldwork has been in, since I got to UT in 2004, in Crimea, now occupied by Russia, and then more recently, since 2016, in Romania. And I'll talk about that a little bit, but that's the sort of the background of what I'm going to present today. And I'm going to speak very briefly, in the interest of time, about a 15-year arc of engagement with high-performance computing on campus in the context of this humanities work. So, how did this start? Well, around 2000, most of us working in archaeology in the ancient world started using computers more regularly as a way to document what we were finding. When I first went to Crimea in 2002, we were still taking pictures with film cameras. When I came back in 2004, everything was digital. And as that became more important, and as GIS became more of an important platform for the management of spatial data, and as databases became easier and easier for non-database developers to use, we started shifting most of our material, most of our documentation of the work that we did in the field into these digital formats. Because it was convenient, it was easier to use, it was easier to integrate, it was easier to interpret, it made nicer pictures for publication, but we weren't really thinking about what we were going to do with all of that digital data we were generating. Either in terms of research, we were still thinking about the research pretty typically, or in terms of storage, long-term storage and preservation. So in around 2008, I was starting to worry about this pretty substantially for a fairly large, in humanities terms, data set that had been collected during excavations in the urban center of Kersnesis in Crimea. And we're talking about maybe a couple of terabytes, so tiny data by computational standards, but large data by humanities standards, and complicated data. A database that started as an SQL database and then became a MySQL database and then was largely based on PHP. We experimented with the generation of three-dimensional data using photogrammetry, using topographical survey. We managed most of our data in a large GIS with multiple kinds of data incorporated in it. We took thousands and thousands of digital images of our stuff because suddenly we didn't have to pay for developing and printing film anymore, so it made it a lot more attractive to document everything. It's a truism that archaeology is a destructive discipline. Unlike a scientific experiment that you can replicate again later given the methods, we take away the thing that we are observing, which is the arrangement of objects together in the soil. Once you excavate the soil, there is no way to reconstitute that. So the only information that you keep is the documentation that you gather, and that only is useful if you can keep it accessible and interpretable in the long term. If you write everything in a narrative notebook, you put your notebook in a repository, 100 years later somebody can come and read the notebook, and we do all the time. If you put it all on a local, a zip drive or something, and in a format from 1985, in 10 years, nobody will be able to get to it, and you won't even remember how you coded things. So the collaboration with TAC came out of a desperate attempt to figure out what to do with all this data before all the pieces of it broke and we lost the ability to preserve it in the long term. And so we started working with specialists at TAC, with Maria Esteva in particular, about figuring out ways to automatically extract metadata from some of the files that we had not provided metadata for when we were collecting them, like image files, and to extract that in a structured form that would allow storage and retrieval in a repository, in this case, iRODS. And that initial collaboration didn't cost us anything because TAC was interested in the questions. So it met the humanities criterion of being free. And it was an interesting challenge for TAC as well. And they had the storage architecture and the computer specialists who could help us figure some of that out. So we built a nice system that fed data out of the database into XML documents that automatically extracted metadata from file names, also into XML documents, and then put that all in an iRODS repository where you could easily search it. Most of that doesn't work anymore. The data's still there. The XML records are still there. All of the interfaces that we use don't work. The database itself is based on an outdated version of PHP. It was built to be done by the developers who were paid by contract and now aren't working on it anymore, and now it is security quarantined. So you can't even see it unless you tunnel in to TAC. So we had a problem about the management of complex relational data. In the long term, we partially solved it through collaboration, but then we were left with these other problems. That led to a longer-term collaboration with TAC, again, to try to figure out what our data workflows were, to define and describe those, and then to find visualization tools to figure out where all of our duplicate records were. So we had a 2 terabyte data set in a 5 terabyte hard drive full of data. Which things were duplicates? Many of them. Which things were versions of each other? Which things were outdated? We didn't know. So we were working with TAC at a sort of meta level analysis of our own data to figure out where we were storing things that didn't need to be stored anymore. So that continued for several years. And in the later part of the 20-teens, the software that allows you to process a collection of images taken from slightly different angles with overlap to create 3D models through what's called photogrammetry reached ease of use and a price point that made it available to humanities researchers. And somewhere between 2012 and 2014, most archaeological sites started documenting their stuff with photogrammetry as well, creating 3D models, which now we also had to figure out how to store, create, and manipulate. So in 2018, I had a collaboration with the Viz Lab at TAC, which was really meant to just have a cool place to display 3D stuff and spin it around for a class of students I was teaching. But that led to a conversation about the role that a high-performance computing cluster could play in the creation of these models, which are computationally intensive. And that, in turn, led to a collaboration where we purchased a consortium of people, including the UT libraries, chipped in to purchase a floating license for Agisoft Metashape, and installed it at TAC so that it could be spun up on any node that was available. And Paul Navratil of the Viz Lab and an undergraduate student developed a Python scripted workflow so that we could start up a virtual machine, load the pictures in, turn off the virtual machine, do a command line execution of a Python file that is just that, right? It's 70 lines. And then it would align your photos and create the initial point cloud for your image. Huge saving of time and computational power for us, because now we're doing this with hundreds of layers at an individual site, and sometimes with data sets consisting of thousands of images. When you try to do that on your laptop breaks or is tied up for 27 hours, which isn't very helpful. And that led in turn to opportunities for digital humanities work involving students. So the computational photography side of this has turned out to be very productive. It's very interesting. It creates 3D models, which are cool to spin around on the web. And in 2019, I taught a graduate seminar on digital approaches to antiquity, which involved the photogrammetrical documentation of an exhibit at the Blanton Museum of a set of casts of ancient sculpture that had been draped and displayed in a particular way by an artist named Lily Cox Richard to comment on polychromy and traditional art. And that turned into a Humanities Texas grant that turned into a website, and we did photogrammetrical captures of 28 of those casts and arranged them in a website that was partially funded by Humanities Texas and then partially supported by LAITS, the Liberal Arts Division of Instructional Technology, and by TAC, where we ran those model processing workflows, with the result that you can go and spin around models of these casts that are in storage and not available to be seen by the public. And I use these as a basis of an extra credit assignment where students in an Intro to Ancient Greece course can download the OBJ files and vertex paint them in ways that they think would be interesting and then re-upload them and display them on the site. So if you want to go look at what those students did, you can see that up on the site now. The other context in which I have worked with TAC in particular is in the context of a UT Grand Challenge project called Planet Texas 2050, which has taken advantage of, I think, all of the resources that were presented today. There's been work in Oz, there's been work in Google Cloud, there's been work with Azure credits. And what we were doing there is a vast multidisciplinary effort to try to ensure that Texas is still sustainable and resilient and a reasonable place to live by 2050, when there will be twice as many people and the dry line will have crossed the line of cities that run from Dallas to San Antonio. So no water where we need it, more water where we don't want it in Houston and the bayous, and 55 million inhabitants, almost all of them in urban spaces. And so we worked with TAC to start developing some information architecture where we might bring together different kinds of data sets and merge them in ways that would allow us to see patterns based on different data layers, and then create dashboards where public organizations and first responders could access them to see where, if you got this much rain in Houston, it was going to be likely to flood. So we worked on this with them, and the DataX platform that I'm showing you has largely been surpassed by a larger project that has been folded into the Texas Disaster Information System. But the basis of that was this collaboration. And the last thing, because I have to, and you all did as well, so I don't feel bad about it, is to talk a little bit about the potential of AI for humanities research, not only for text, right? And there is a big role for humanities and things like ChatGPT. Chris's ChatGPT question about what higher education researchers are interested in. I don't know if you guys read the answer, but the answer was, what are people who research higher education interested in? Whereas the question was, what are people who do research in higher education interested in? So it misunderstood the question and gave you an answer on the basis of what it thought was likely to be what you were asking. That's a humanities issue, right? That the way language works, that's us. So, but there's also a whole set of things related to spatial data and satellite imagery. And I've been working with a recent PhD student from geography, Layla Character, on the creation of an AI model that will identify the location of burial mounds. That's what I started with, those mounds in the landscape. In Romania and southern Ukraine, that's where people were buried for a period of about 2,500 years. And they say something about landscape and time and memory. And there are so many of them that it is impossible to identify them on the ground. Many of them have been plowed over in the last 50 years, so they're just a sort of a light circle from aerial photographs. And it's not even really feasible to have somebody go, 500 meters square by 500 meters square to identify them by hand. So we wanted to apply computer vision to this problem. And what I'm showing you is some of the model training where we had students work on identifying tumuli by hand to provide training data, and then a comparison between the green dots, which are an existing database of tumuli gathered by the National Institute of Patrimony in Romania, and that series of photos there, which are the existing dots, which are not exactly in the right place because of the survey and projection issues, the predicted locations, which are the red dots, and the ground truthing of those predicted locations, in which the ones on the upper left that are now in purple were in fact plowed out tumuli, and the one on the right was a modern feature that happened to be kind of circular. So there's a lot of potential here. We actually attempted to do this using Azure credits on Azure, but because Layla had built her model using dependencies that were already outdated, she found it easier just to run it on her computer. So we go back to this question of how you work in a humanities environment where you're trying to build things one time to do a specific thing that's highly customized, but you're generating things that you want to be able to be ported forward, either as data that people can reuse in 70 or 100 years, or as a model that can be used, and this is what we're working on now, reused and reapplied to southern Ukraine as a heritage monitoring device to keep track of tumuli that are being destroyed by the war. So these are just some of the ways that the humanities are involved. And smaller scale, more idiosyncratic, more complicated, but the potential for discovery is there just as it is in the sciences. We just tend not to do things that people have already done or that anybody is going to do again in the same way. Thanks very much. I'm happy to take questions, but I think we're over time.
Yeah, so we will still have time for questions at the end if you're able to stick around. Thank you, Adam. Unfortunately, I think something got unplugged, and so on Zoom, they weren't seeing the slides for the portion of the presentation.
I can send them.
If you could send them, yes. So, for all the presenters, if you're able to share your slides with us, we'd be very glad to post those online along with the recording. So for anyone that's attending on Zoom, we will post those on our website. We will send the link to everybody that's registered so that you have that and you know where to find those materials and access the Zoom recording. All right, we're trying to fix that issue. Russ, I don't know if you have any slide. Okay, great. So hopefully we can get that issue resolved. And I'd like to welcome up Russ Finney, who will be speaking. He's our vice chair for the C13 Information Technology Committee, and He's going to be talking about the importance of research computing and give some concluding remarks.
Yep.
Oh. So let's go ahead and adjust it out.
Oh,
Okay, thank you very much. So I'm going to wrap us up. I've only got just a couple of slides, so it'll be quick. But I'm Russ Finney, and I'm the vice chair of the C13. It's the information technology. It's the faculty voice for IT. And I'm going to talk a little bit about what we're doing, and then how you can influence all this stuff that we just heard about. So a lot of this can be done through our group, and I'll explain, how that can happen. I'm at the McCombs School of Business. I'm an assistant professor, and I'm also the director of the MIS undergrad program. So we teach about IT. So there's two committees, faculty committees in the governance structure at UT that deal with information technology. So one is kind of a broad committee. That's the one that I'm on, the C13 committee. And we look at everything across the whole spectrum of IT. And we also have another committee, which is referred to as C14. If you're a vendor, you can find all this on the web. But the C14 focus on enhanced instruction through technology. And you can imagine they've been pretty busy, especially with COVID and online learning, and we added a lot of technology in a really rapid time frame. Pretty amazing what UT did over the last 2 or 3 years. What we focus on is policy and strategy recommendations. So certain policies for using things, certain strategic initiatives that are going on. At UT, are you picking up on the fact that there's a lot of strategy initiatives happening? So we've got an overall university strategy initiative. That's all been released. And then there's been a rollout. There's a really huge meeting this week on our information technology strategy. And it's very broad. It covers almost 7 years. And I listened in on that the other day for the town hall. There's a lot of stakeholders in information technology at the University of Texas. There's the administrative group. And of course, we've got all kinds of legacy applications, some that have been around here for years, that support the business of teaching and the business of research. So that's administrative systems. We also have all the student supporting systems, student learning, and you could actually add parents, to the stakeholder set. We have a lot of parents that go in and use our systems. And then the last is the faculty and the researchers that depend on technology. That's what we represent with our group. So this year, we've been focused mostly on catching innovation and improvement suggestions. So I felt like our committee has been somewhat of a suggestion box committee. So if you got something interesting to share or an idea out of your college, some thought on an improvement, let's hear about it. And so we've been capturing literally dozens of these. They feel a little bit random, like as you look through, it's just whoever kind of has a bit of an agenda to get something done, then they'll pipe up and make a suggestion. But I think in next year in 2024, we're going to be a little bit more systematic about it. So thinking about the faculty and researcher, their journey, and what are they trying to accomplish? What's the outcome they're trying to get to in learning or their research or whatever it may be? So really looking at that a bit more holistic. and thinking about the different use cases that our faculty and researchers are confronted with. So you may have a lecturer that comes in, they're just teaching a class part-time, they need a certain amount of technology, what's their little journey? But then you may have a researcher that's out there with a very large team, very complex, needs all the resources that we just heard about. And what does their journey look like? And obviously that's going to be quite a bit different. So we want to see what all these use cases look like, at least the biggest, broadest ones, and then harmonize that into this overall IT strategy that's rolling out right now, harmonizing the voice of the faculty and the researchers into that. So what will we focus on? The use cases on the scope that I just mentioned. We want to identify gaps. What's missing in your journey? What do you need? What can we suggest? What policies need to be implemented? What things in the strategy need to be accommodated? And then maybe given a bit more visibility of the policies and recommended, I called it recommended / available resources based on your use case. So we heard a lot of resources today, right? We heard resources from vendors. We heard resources in our internal groups. Some are quite sophisticated, supercomputers, clusters and things. I think for someone who's rolling out something new, it's a little daunting. Where do I start? Which resources should I use? Should I go maybe talk to Google about this thing, or AWS, or when is it appropriate? So I would welcome the vendors that are in the room to give me a little more input about what use cases you feel like would really be your sweet spot, rather than here's your technology, yada, yada, yada. It's helpful to know the use case so that when somebody has the situation, we can guide them in that direction. Like, oh, wow, you know, AWS does that one really well, or that's one that we know Microsoft's helped us with. So use cases help. I also think for some researchers, when do I go to TACC? When should I use these library storage things? So anyway, we want to focus a little bit more on a use case base, finding gaps, making sure the gaps are filled, and then having some guideposts. Not necessarily hard policies, but guideposts on where to go to get your resources. So how can you help? Find your C13 representative, and if you have things that need to be brought forward to us so that we can get this in our next report, you can either communicate or even join our meeting. You know, come in with the rep and help us to understand your use case. Here's my contact information. So I'd love to have the vendors in the room reach out to me so that I know more about what the capabilities are. I met most of you already, so anyway, but feel free to share. Especially the university use cases, you know, not just your features. And the last thing would be, if you're out there listening, or if anybody actually made it to the end of this, feel free to contact me, connect on LinkedIn. If you want to be more involved, just send me an email. So there's my email address, and happy to communicate with you. I'll be focused on this all the way until next spring, so over the whole year. So we got a lot of work to do. Thanks, Michael. Now, thanks for inviting me.
All right. Well, I want to thank all of our speakers. Thank you for making time to come out today. We really appreciate it. Thank you, Angie Newell from Information Technology Services for helping to organize this. Thank you for everybody that has attended, and really appreciate you sticking around on Zoom. I know we've gone about 15 minutes over. Fortunately, most of our speakers have been able to stick around. If you have a few more minutes in case we have questions from the audience, If you are listening via Zoom, and we still have about 30 people, it looks like, online, please feel free to submit your questions, and we'll be able to ask those out loud. We have a microphone here, so we can share those out for people in the audience here in the room in Learning Lab 1, and we can also then, everybody that's still on Zoom will see those in the chat. So please feel free to post those. We'll give it a few minutes, see if those come in, and we will relay those to our presenters. If you have questions after the fact, we will be, for those speakers, do you have slides that we can share? All right, fantastic, great. So I think you have contact information that was included in there, so hopefully folks will be able to reach out to you. Again, we will be sending an email out to everybody that registered, so you can have a link that points you to where all these resources are going to be made available online. They will be put up and made available longer term, so you'll be able to access this information anytime you want to refer back to it. And then, of course, you can reach out to our speakers. You can reach out to myself if you have any questions, and I can also forward you to the appropriate person. So thank you again for attending, and yeah, we'll see if any questions come in. And I think we might have had a few questions earlier online. Were there any that we weren't able to address while folks were presenting?
There's one for Dan, but I'll
Okay.
get it to
Yeah,
him.
unfortunately, it was one about TAC resources, and Dan Stanzione had to leave a little bit earlier due to a scheduling conflict. So maybe give it another minute if anyone's sticking around to ask their question. Anything coming in? Okay. Well, if not, that's completely fine too, right? Again, those resources are going to be made available, so you'll have the contact information for all of our presenters today. All right, and since we are over time, I think we can go ahead and conclude. One more thank you again to everybody that spoke today. I'm really glad to have you all here, and hopefully this is something that we can build off of and leads to future collaborations. I'm really excited to have made these connections, and I'm looking forward to working with all of you that were here today, folks that are online. Hopefully, again, you know how to reach out to, and this results in additional collaboration there, and we can start to work together more successfully to take advantage of these great research computing resources that we have available to us here on the UT campus. All right, I think we can go ahead and conclude. Thank you, everyone.